Hello and welcome to this edition of Radio Free HPC. This is where we talk about supercomputing, high-performance computing, and other technology topics. I'm your Toastmaster, Rich Breckner, with my co-hosts, Dan Olds and Shaheen Khan from OrionX, and Henry Newman from Seagate Government Solutions. Now let's get to the show. All right, folks, we're back with a special edition of Radio Free HPC. This is Rich Breckner, and we have the full crew today. Shaheen Khan, Dan Olds from OrionX, and Henry Newman. So welcome back, guys.
We have a huge day today.
Huge. We've been hitting at this for a couple of months now, I think.
We have. We've got a big announcement, Rich.
Well, Dan, I think we should just get right into it. I got slides up here. It says Project Cyclops. What is this?
Project Cyclops is our shot, our Radio Free HPC shot at fame and glory.
Oh my.
We're attempting to build the fastest, biggest, baddest single-node supercomputer in the world.
Okay, so not a small
and
task.
Dan, how do you define? Let's tell the audience how we define that.
Yeah.
We're going to define that by posting the biggest single-node benchmarks on a number of measures.
That's the goal.
That's the goal.
Okay.
So there will be evidence.
There will be evidence.
Mm.
And moreover, we're going to put up a single-node supercomputer benchmark site on our Project Cyclops site that will be a constant leaderboard and essentially a testament to our awesomeness that all can see 24/7.
Dan, you're putting the cart before the horse, baby.
Yeah, I don't know if there's any numbers here to back up that kind of bravado.
Not yet.
Yeah,
Not yet.
can see. Dan, you know what? It's nice you think that. It's always good to have goals. But beating your chest as an ex-benchmarker before you hit, you get your first number, or even before you power the system up, might be a little cart before the horse, buddy.
Well, Dan is definitely in love with his own secret sauce for this. So
I think this is going to be outstanding.
Oh.
So Dan, give us a bit of a mythology of Cyclops.
Well, this all came about from a conversation that we had, guys, a couple of months ago about some of these benchmarks like HPCG, HPCC, Graph 500, and I'm forgetting about one right now, but it's kind of the
Green
four
500
benchmarks we're going to do. Green 500, but also HPL.
Yeah.
And other than HPL and Green 500, which is a sort of a synthetic blend of WinPack and electricity, some of these other benchmarks aren't getting a lot of attention, and we happen to notice that, for instance, the Graph 500 doesn't have 500 systems on it.
Yes.
And then we were wondering, hey,
it's an easy picking then.
What if we decided to put a system on there?
We would actually be on by default just by submitting. We'd be part of it, right?
Which to me is just a huge win.
But I think Dan wants to
Winning
be
by
like
default is
#1,
just
right?
a huge win.
Okay, well, I think, it got more ambitious after that, though. We didn't want to, we
Well-
weren't content just to be listed.
We didn't want to just take one of our PCs or laptops and run this stuff.
Yeah.
And that sort of led to, I wonder if we could get some sponsors for this.
Mm-hmm.
I wonder if we could get if we kept our ambitions somewhat modest with going single node, and again with the idea that in building a supercomputer, the proper way to do it is to get the first node right. Then you build out 10,000 more.
Well, not necessarily, Dan.
It is in our little world.
Yeah. So we're like optimizing the other end of it. Instead of saying, how can I make 10,000 things go fast, we're saying, how can I make one thing go fast? And that may lead you to different configuration.
Yeah, definitely.
Yes. But what I like about this is that individuals out there have systems on their, on their floor or, under their desk, and they're going to want to have the fastest they can get locally, and this would be the way for them to do that.
Well,
yes.
but that is. But also remember, one of the other things we were challenged with was power and cooling, because in Dan's house, which is where this is going to be located, it's not like we have a rack. And Shaheen, you made the point people want on their desk. This might be a good cookbook for other people,
Exactly.
based on their computational requirements.
Yes, exactly.
Or maybe a great way to roast hot dogs at home. So
Well,
Or
we'll talk about that.
I also want to remind
we
you.
are taking a collection for Dan's electricity bill when we're running the benchmark.
Oh, he's got the solar panel going too, right?
Oh.
In Portland.
yeah.
Better do it before the winter hits.
Yeah.
But you
There's no
have to
sun.
remember that this whole scale-out stuff started with Beowulfs and strapping together a bunch of workstations.
Mm-hmm.
So having fast single nodes is also a pretty good recipe to build at least medium-sized clusters.
Well, and Shaheen, there are still codes that don't scale well, and there are still codes that are very sequential, and communications doesn't scale. So this, there are still those codes.
Yeah, very true, very true.
Well, and let's not forget that our friend Wolfgang at the Uber Cloud did a survey, and 99% of engineering jobs are still done on the workstations, not
On
in clusters.
station.
Yeah.
That doesn't surprise me.
Yeah. Yeah.
And the other thing that we're going to do in this, in deciding to put our own system up on the charts, we want to bring attention to these benchmarks.
Yeah.
We also want to get others in the game and prove how far technology's come. It's come a long way. And of course, what I'll be specializing in is taunting people into participating.
Yeah. Well, good.
Well,
I'm good at
and Dan will walk around, I'm sure, at supercomputing and talk to the student cluster people and say, "Look what I did. Can you do better?" I know Dan.
Oh yeah. Oh yeah.
Dan, with a name like Radio Free HPC, this is the first time I believe we've done something that feels a little rebellious, right?
It is a little rebellious. Yeah, and by the way, at SC17, well, let me just hold that back. Let's go through.
Okay.
I think we ought to go through what this thing is going to be.
Let's start with what your tagline is for this.
Yes. Our motto on our Super Omnia Una, which means one above all.
Oh.
Yeah, we've got a custom Project Cyclops logo.
Nice.
And we've kind of gone through a couple of the first slides and talking about the first initial benchmarks we're going to run, HPCC, HPCG, Graph 500, then we'll do an HPL as well. So we're going to put up the single node supercomputer leaderboard, and we're going to have a website. That'll be a website where we track our Cyclops benchmarks and challenge others to match them. We're going to keep benchmarking this thing, and we're going to keep working to optimize it. And this will publicize those results. And if there's ever a Cyclops 2, it'll stay there too. We'll talk about that a little bit later.
Your wife is going to let you have that much power and cooling in your house?
She has no idea how much that is.
Okay. Dan?
Yes.
You can send your first check over the weekend.
Well, we'll talk about the some of the things some of the enhancements that we're going to be putting in this system to belay some of those costs. We're going to be publishing articles in various, especially inside HPC. That's going to be our media hub, and on our Project Cyclops leaderboard, our articles will appear there too. The system is going to be appearing in Supermicro's SC17 booth, by the way.
That's excellent.
Nice.
They are one of the sponsors. They are providing the chassis, the motherboard, power supply. That would be dual 2,000-watt power supplies, my friends.
Ouch. Oh.
And we're going to need every one of those watts.
We're going to
have and do you have a circuit in your house? You're going to have to redo your circuitry in your house. Do you have enough for that?
Yeah.
I've got 60 amps to my office. I think that'll be fine.
We'll see.
That's like an arc welder.
With all the other stuff.
Well, yeah, I'm going to be unplugging some things. Yeah, I'm looking around. Yeah, there's some stuff that's going to have to go.
Turn off a few lights.
Yeah.
So what we're doing now, or what we have now, is a chassis from Supermicro. We're very grateful for that. It's a two-way workstation. The model 7048 GRTR What's different about this one is it has the wide motherboard spacing for GPUs.
Mm.
And we will be taking advantage of that.
And the other thing about that is, besides the spacing for GPUs, it's got the PCI bus to allow you to put GPUs, and the way the CPU sockets work, you get all the bandwidth to the GPUs on those bus slots.
Yes. Yes.
So
Wow.
that was one of the criteria I had as part of the design of the system that Dan and I went back and forth on.
Yeah.
You're going to use a lot of GPUs. You better have PCI bus slots that can use them.
Yeah, and you examined that closely.
Yes.
Let's go next. We have our pals at Kingston Memory donating 128 gigabytes of speedy DDR4. So yay for that. 128 gig will get us quite a ways down the road, but this doesn't fill the machine up, so we can add more memory to it as needed.
And that's slide 10, by the way, folks.
That's slide 10.
Oh, gotcha.
Slide 11. Henry, you want to talk about this?
Yeah, we've got you a couple M2 SSDs. I'm going to try to upgrade them to next generation. But we're going to use this for things like compile, for, and a number of other things we're going to look at using them for. This is part of the optimization plan for these codes, see how we can take advantage of them in the benchmark.
Yeah, and these will be damn fast.
They will
be orders of magnitude faster than SATA 3.
Yes, they will be.
Wow, nice.
Now, here's your question, Rich, on the next slide, 12. How are we going to cool this thing? We're going to liquid cool this thing.
Mm-hmm.
What kind of liquid?
It's probably going to be treated water. So treated so that it's non-conductive, distilled water, and treated so you don't get, a terrarium growing in there.
You're not doing immersion, right? Are you doing immersion?
Looked at immersion, decided against immersion.
Just too difficult to do in an office.
There are challenges of immersion for some of, for example, for NVMe cards and GPUs right now. Shaheen, it can be done, but not in this short time, and not. I'm not sure we can get the NVMe done for sure, given those slots.
I would feel comfortable with anything except the drives, because you've got to waterproof the drives. That suck.
Now, are you cooling
it?
It
Also makes it. By the way, it also makes it a little bit difficult for the DVD drive.
Yeah.
And Shaheen, the other thing it's difficult for, and not that this can't happen in the future. I'm not poo-pooing immersion, but shipping it for supercomputing.
That's
yes.
Right.
Oh.
Yes.
So
that's a big component.
There were a lot of considerations that Dan and I went over when we kind of went this route.
Okay.
I believe I even brought up liquid nitrogen, but that turns out to have some problems too.
Well, Dan was again, I don't know if you all saw that AMD thing from about 5 or 6 years ago where people were pouring, I think it was liquid nitrogen on a CPU and clocking it at 8 gigahertz or something.
Yeah. Exactly. I saw that.
Yeah,
until it explodes.
Something like that. It didn't explode. It
bubbled a lot. It
bubbled a lot.
like a volcano.
Yeah.
But what we're going to have are water blocks on each CPU.
Mm-hmm.
That's one loop. Yeah. And then on all 4 GPUs, 2 of them to a loop each.
Mm.
And
you're going to air cool the rest, or how do you do the heat exchange, Dan?
The heat exchanger. My office is upstairs. It faces the west. It gets the afternoon sun. It's the hottest room in the house, even without all the equipment I have. So what I'm going to do is this office backs up to a small attic, and that attic has roof vents that vent to the bottom that let in cool air. But we also have a whole house attic fan that when it hits 85 degrees in there, it kicks on and starts pulling some incredible amount of cubic feet per second out of that attic. So what the heat exchanger, I have a hole through my office wall into that attic, and I'm going to be piping through it and have the heat exchanger in the attic.
Excellent. Now, Dan, are you cooling enough to overclock a bit?
Oh, yeah.
I assume this thing has CPUs, right?
Has CPUs?
Yeah.
Yeah,
'cause we
yeah.
haven't
Well,
talked
yeah,
about
we've got
CPUs
two
yet.
CPUs. We're gonna come to that. Yeah, we're gonna have processors. But yeah, we'll be doing some attempt some overclocking on the CPUs. I'm not sure how much this board lets us do.
Yeah.
It's really up to the board and the firmware on the board as to how much control you have.
And I am sure you can go on the dark web and get a BIOS and overclock this with a BIOS improvement.
Jailbreak.
That's an idea.
I know
That's
you're on the dark web looking for my Social Security number after
I am.
or earlier this week, but
Yes. I'm making sure that it's clean of Henry Newman.
And
we will be overclocking the GPUs, of course, too.
Well, and we part of the CPUs will be used for computation. GPUs, we're going to distribute this and distribute the computation, so we're getting as much out of everything as we can and going
exactly
flat out.
Now let's go to the next slide, and that talks about the processors and the GPUs.
Okay.
Our pals at Intel have very generously offered to donate a couple of CPUs.
Excellent.
What we chose were the 2678W V4, 12 core, 3 gigahertz, 160 watts. We could have gone for more cores, but the problem is you're dropping the frequency with those. And to Henry and I, this looked like the best option in order to get the most power out of these things.
So is
most
this
compute power.
Is that a Broadwell or what is that? That's not
a Broadwell.
Skylake.
No, it's not a Skylake.
Okay. Haswell?
Skylake was still a little too new when we were starting our investigation into this. We couldn't get a motherboard for it.
Gotcha.
And that was the issue, Rich. And when Dan and I were talking, obviously having more cores might work, but we don't know. And with the memory bandwidth and all this. So to be totally honest, this was what I would call an EWAG, educated wild ass guess. So this is our
Okay, fair enough.
Sounds like sounds pretty good. This is a good place to go.
Because this thing, by the way, in turbo mode, I believe we get to 3.5 gigahertz.
Correct, and then we can turn vectors on and all that. And if we've got the cooling we need, we could potentially run those vectors flat out. So that
all the time.
And if that was the case, we weren't sure that given the codes, that given the memory bandwidth we had and memory bandwidth requirements, that anything bigger would be any badder.
Yeah.
If
that makes sense.
It might be less bad.
It might be less. As I said, Dan and I spent a lot of time on this.
We really did.
Okay.
Now we're also going with 4 consumer Asus 1080 Ti GPUs. These are the biggest and baddest GPUs out there right now, and they're in huge demand. The price has gone up by more than $100 on them since introduction.
Yeah, they're
high.
Talking
consumer oriented, or
these are consumer. Yes.
Right.
So you see, that's another interesting part of this is that there's a lot of performance to be gained by going consumer route rather than server route, which is really the heart of HPC. HPC's always managed to get performance out of the cheapest thing we can get, right?
Yeah.
And, Shane, maybe when you started, because you're younger than me, but when I started, that was not the case. People spent a lot of money. I mean, you are clearly a lot younger than I am. If you hit me with that statement,
I would still argue. I think you're both older than I am. I would still argue that even today, I mean, you started out with HPC systems being, carved from a single hand carved and hand wired, which was hideously expensive. Then it went to Unix boxes, which were cheaper and worse. And then it went to essentially.
But anyway, price performance has always been paramount.
Yes.
And we keep forgetting about price performance occasionally. But at the end of the day, price performance is a really big thing. And if you can use the desktop that is like 80% of the performance, but fifth of the price, then you're way ahead.
I totally agree, Shaheen. And I just thought of something that's kind of interesting as part of all this, of what you said. If you go back to when the 6600 was introduced and look at, kind of the last of the big vector machines and the introduction to the, parallel processing with commodity processors, we've had 2 eras of HPC, if you look at that, they're about the same time period now. 6600 to, maybe C90, or, there was a Triton, but, this called the C90 was fairly successful.
C90 was
YMP
excellent.
C90 to, the commodity processors in the mid-late 90s to now, that's about the same amount of time.
Yeah.
That's interesting. Are you prophesizing we're getting ready for another inflection point?
No, I'm not, Dan, but it's a possible.
It certainly is.
We may be due for something.
There's enough going on that may just happen. There's lots of innovation.
Lots of research, lots of new stuff
but
coming out.
I just, it just dawned on me. I'd point that out when I was talking about how young Shaheen is.
Yeah.
That is an interesting point. Now, the other thing that Henry used to be one of the baddest, slimiest benchmarkers in the land.
That was a long time ago, Dan. That was my misspent youth.
Oh, yeah.
And since we can't benchmark this using cards or paper tape, we're going
Thanks, Dan.
I mean, benchmarking is a young man's game.
Yeah.
It is.
It is. And we're going to have some help on this from the folks at Redline Performance Solutions, who Henry and I both know fairly well, and they are excellent at doing this stuff. And they're going to run these benchmarks and these other workloads that we're going to do bare metal, unaltered, and then they're going to go and do their stuff. They're optimizing magic and show us what the difference in the results are.
And we're going to list those. So in things like large pages and those kinds of things that we've talked with, and we're going to have a list, and we're going to do it one at a time so you can see the differences and put them together. It's not going to be here, we're going to do it stepwise, the right way.
Yes.
Yeah.
And we're going to
but looks like a great
as possible go explicit on the steps so people can see what benefit they got out of everything they did.
But it looks like a great team is coming together to make this happen.
Yes.
Yeah.
Yes.
And by the virtue of this machine should be a beast with good performance out of the box, but just to show what modern code can do to something like this, because there's a lot of parallelism inside those Xeons and those GPUs, and you got to exploit that well and smart, like.
And speaking of exploitation, Rich, one of the things I'd like to throw out, and I just thought of this, and maybe we can get some help from some people and maybe our listeners, is compilers. Because that's a big part of this, is compiler options and various for these codes, and what we should use. Dan, I mean, there's GCC out there, there's Intel,
PGI.
PGI, we should be looking at all those things. PGI is a local company for you guys, right?
Well, yeah.
For sure are. Yeah.
Well, hell, Intel's a local company for us too.
Yeah, I guess they are.
I mean, there's more Intel people up here than in California, from what I hear.
Yeah, quite a few.
And Dan, why do you go over the last slide? Because I think that's an important thing, and I think it's critical to our industry. Because, except for Shaheen and Rich, we're a bunch of old guys.
Yeah. Yeah, no kidding. Well, what we're hoping, and this came out of the meeting with Intel, because they were very interested in having an educational angle to this. Yeah. Rich and I met with them, and what we're hoping to do is to turn this into a multi-year initiative, and in 18 months or so, refresh this system into a new box based on Perley, call it Cyclops 2, but take Cyclops 1 and donate it to an educational institution.
And the other thing we're going to do is we're going to document everything we do so people can take, a bare metal box and duplicate our efforts step by step.
Nice.
So, I mean, in educational, so people, if you're a school and you want to get into and understand what these HPC applications are, you can take, download a Linux, here's what you do, and they can try things on other systems. And we're hoping, that more people enter the HPC field. Because we critically need that.
Yeah.
You think about the uses of this machine. This is going to be a dual boot Windows and Linux. And I'm thinking about this going to a high school or a community college where they have a serious machine that can do anything from advanced AV processing and video rendering and animation, and then over to scientific applications.
Well, nice. I think that's a great way to spread the goodwill we're getting from our sponsors, Dan. And I think we should list who you have that have helped make this possible at this point. So
I will.
We mentioned
I'll update
Intel.
the slide deck. We're sending it to you. It's Intel, our pals at Seagate, including Henry, Kingston Memory, Redline Performance Solutions, of course, and a liquid cooling vendor that I can't name yet because we're still working on the configuration.
Okay.
So stay tuned for that one, and we'll talk about that in detail in an upcoming broadcast.
And of course,
and Dan, one of the things we need to get is we'll need some video of what you cutting holes through your house and all that. And most importantly, the thing I want when we do that is I want a separate video when your wife walks in the room and sees the hole in your house.
Well, actually, my current liquid-cooled system is utilizing exactly that model. And I got to tell you, it took 15 to 20 degrees of heat out of this room.
Wow.
Just doing that.
Yeah.
Because I'm running a 2 GPU system that's liquid cooled, and making that change to put the heat exchanger, get it outside of the room is great. So it's just a small matter of engineering to get different pipes through there.
But also remember, time is of the essence. We got less than 7 weeks.
Yeah.
It's getting close.
Yeah, the race
is on. We gotta go, as I say, head down, ass up.
Well, we're just waiting for the hardware to come in.
Yep.
And we'll be doing some testing, get it set up with the operating systems, and then let the guys and gals at Redline do their magic.
Very cool.
Yep.
All right.
Excellent. We'll need to get the Redline folks on a Radio Free.
Yeah. We'll get Dawn or Carolyn on, or both.
Yeah. Very cool. All right, guys. So we've launched this project. It's a reel today. And we'll put a link where you can find out more about it. I believe there's a press release coming out. That'll be on Inside HPC. And Project Cyclops is official as of today.
And Rich, why didn't you put a link on the Radio Free where we talked about the various benchmarks and what was the impetus? I think it's from about 6 months ago.
Yeah, we can definitely do that.
Yeah, and also the site for Cyclops will be coming off of Radio Free, so you'll see a great logo on the top of the Radio Free HPC banner, and that'll lead to the sub-site for Project Cyclops.
And that's why Dan needed 2 GPUs, is to render that banner and the logo.
Yeah, I can see that.
You would not believe what Shaheen and I went through to get that logo just right and have exactly the right colors.
Yes, I do. I heard the ranting.
Yeah.
Everything about this has been
And
painstaking.
speaking of ranting, Dan, I hear you have a rant for the week.
Yeah. There's been some buzz about that.
I've got a very short rant this week,
Mm-hmm.
and it's about people that do not put their contact information in their signature block.
In their email.
I don't want to get an email in their email signature block. I don't want to get an email from some guy saying, just at the end of it, Dave. I want to see Dave. I want to see your last name. I want to see what company you're with, and I want to see a phone number. Is that too much to ask?
I mean, you don't want to just see that line that says, it just says that line sent from my iPhone. What else do you need to know?
Yeah.
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 That's real helpful, don't you think?
Wait, sent to my iPhone. Excuse my brevity, you forgot that part.
Oh, yeah.
And my typos. Sent my iPhone, and I don't remember the number of it, so I'm not going to put that in my signature block. Come on, people. Put a little effort into your career.
Just a little.
Because people are going to occasionally need to call you, or they might not remember what company you're from. Just put it in there.
Dan, this sounds like a good weekly regular addition to our.
I am constantly pissed off and enraged about things. And so I think this will be my outlet.
So we have a little segment called Dan's Weekly Rant.
Dan's
I'll
rant.
work up a little opening audio for it.
Okay, maybe we can get even some guest rants, maybe from
Yeah.
the rest of the squad here. So,
And I got a feeling that putting this system together is going to give me some rant-worthy things. Well,
Right.
Oh,
And Dan,
yeah,
at some point, since we will be showing this at Supercomputing, back to your rant, and the listeners, and we will be having a little get-together on Saturday before Supercomputing. And Dan will be talking about that and talk about Cyclops.
yeah.
yes.
Yeah.
Yes. And I think Rich and I will be doing some booth chats, and you guys are welcome too at Supermicro's booth in front of the system.
Yeah.
And we're going to be documenting this with stories as we go, with videos, pictures, emergency room medical reports, whatever we need to go through the entire process.
Is that what happens when you blow your power out in your power panel and you get electrocuted?
It's kind of disgusting, but I found in every project I do like this or some sort of home improvement project that the successful ones, there's always a little bit of blood.
Oh, yeah.
There's always a little something, a cut finger, something like that. There's a little bit of blood, and then that kind of lets me know it's going to be successful.
Well,
That's probably a you thing, Dan.
Yeah.
It seems like it is.
And Dan, do you have a fire extinguisher in your office? Because I think that it's going to be mandatory.
One that's rated for electrical, Dan, not one that's rated for wood.
Some kind of halon system or something.
Yep.
Well, I will send you guys. I'll send you guys a picture of my current cooling stack in the attic, so you can get a sense for that.
Okay.
But I'll also send you a picture of where I built my last system and where this system will be built, next to the HPC Wall of Fame, where I have pictures of famous HPC folks on it.
Okay.
Okay.
Cool.
Sounds
So
good.
what's the catch of the week, guys?
Oh God, it actually been a pretty good week. What do you got, Shaheen? What do you have?
Well, Apple announced the iPhone 8 and iPhone 10 or X, depending on how you pronounce that thing. And one of
I pronounce it Tex.
Oh yeah, the face recognition.
Exactly.
Yes.
So one of this big thing is face recognition, and sounded like it didn't quite work during the demo.
Yeah.
But it's coming. And then related to that, there was a tweet that went by that, according to Alipay, which is a third-party payment system for like transactions and such, in China, somebody in a KFC in China had seen a sign that says you can now pay with facial recognition.
Oh.
So you don't even need to carry a phone. That is pretty interesting if it is true. But it's kind of points to the way of the things, that are coming.
Boy, that's not rife for security hacks at all.
Oh.
Well, I think those who remember Mission Impossible TV series.
The masks.
The mask. Exactly. There was always the mask. Yeah. That always worked.
Well, and I remember what I said a few months ago, or maybe a year ago, on Radio Free HPC about a photographer who took the fingerprint, high resolution of the German defense minister, and made fingerprint masks so he could get.
That's right.
Yeah. So this is an arms race, folks. In my opinion.
Yep, absolutely.
Yeah.
It's an arms race, and we could stay ahead, but for some time. But there needs to be some other, more secure method than face, retina, eyes, fingers. That's a start, but we can't relax if we go there. In my opinion,
all
absolutely
can be overcome.
Right.
I think maybe we go like in Gattaca, the movie, where it was your DNA was how you certified your identity.
But in Gattaca, they overcame that. Remember?
Oh yeah, he spoofed.
He hacked it.
Yes,
that was a great movie, by the way.
Yeah,
highly recommend. Of course, we have we have the technology that solves every problem. Blockchain. Let's just apply that.
Yeah.
Right. That's another thread that's going on. You take any problem that is insoluble, you add blockchain, and you claim you've solved it.
All right. I'm glad you didn't really believe that it's solved forever. Shane, I was getting worried. I was gonna see. You've been hanging out with Dan too long. Then.
No, not me. I don't see that as a panacea either.
No, he's a bit of a Luddite for me. Anyway.
No, blockchain could be part of the solution, but everything will have to be continually improved.
Yes.
I am convinced of that.
Okay.
Yes.
Okay. Well, who else has got a catch of the week?
My catch of the week was Cyclops, the most amazing computer ever to be born.
Thank you, Dan. Moving on.
Dan, I think this Cyclops thing, I'm going to call it Beowulf 2.0 or 3.0, wherever that is, because I think it's it's going to bring back the idea of more of a workstation-centric view of HPC than server-centric. I like that.
My catch is, and I'm not going to name names because it's just too painful, and I don't want to complain too much, but I have now been hacked 6 times in 4 years, with the latest one that was announced this week with 143 million people, which is like a lot of percentage of every adult man, woman, and child in this country.
Pretty much all of them that have a credit record.
Pretty much, yeah.
So I pretty much figured I'm burned for the rest of my life, because people are going to keep this data unless we can have. The only way I'm saved, and the only way any of us are saved, is EMP. We have a big EMP pulse, wipes out all the data. We start over again.
Well,
that's the only way.
Oh, that'd be great for your storage industry, where you work there, Henry. That'd be good. Yeah.
It'd be great.
Yeah,
I don't think that's, and it's not an extreme solution. That's what I like.
Yeah, it's
well
reasonable.
Thought out.
Yeah.
It's reasonable. Yeah.
That's the only way. That's the only way any of us, I think, are safe as we move forward.
Gotcha.
So Henry, do you find that liberating now that you've been hacked so many times? Everybody's got your info anyway.
Yeah.
No, but it's different people. Everybody. Well, everybody on Dan's dark web. But I think I've come to the realization. I was annoyed the first few times, and I was getting angry, but I'm just oh well, what do I do? Here, lock this again, or make sure this is locked, or I've locked everything.
I mean, you were especially upset when they hacked into your hotel points network.
That was
the first Radio Free HPC we did, was exploring that.
It was not a hack. It was a silent data corruption, Dan, remember?
Oh.
That's right. That's right. The awful specter of silent data corruption.
Yes.
What do you got, Rich?
Well, it's just something of note. There was a story this week. We picked it up on Inside HPC. It's about Kubernetes, which is an open source containerization technology, and it has applications in AI, deep learning, and HPC. So Univa, our friends over there, are big proponents of this, and it's kind of nice to see these technologies that are getting traction out there in the data center, out there in the DevOps world, kind of crossing over to HPC. So I thought that was worth noting today.
Does that have the is this a forerunner to virtualizing HPC?
It's just another way to do it, just like Docker is, right? It's just another means to the end. And, just all these things come together as people look at how to take their HPC workloads and move them to the cloud painlessly. This will help.
Yeah.
Yeah.
Whereas
you and your cloud.
Oh, me and my cloud.
Yeah, whereas virtualization by itself always came across to me as a management benefit rather than really any other benefit, because there are not that many spare cycles in HPC systems.
No, right. That's true.
You don't really want to break them apart. You actually want to go the other way and combine them together. So it's kind of aggregation virtualization rather than splitting apart virtualization. Kubernetes and these Docker's containers add they actually add a benefit, which is you don't have to worry about compatibility, and you just get an image that you just deploy and it just runs. So that is a real benefit. to the extent that works. So in that sense, it goes beyond virtualization, and I like it. Now, where you run, I think, is kind of secondary.
Yeah.
And if it's cloud or on-prem or anywhere, it's still kind of the same infrastructure. So good progress there.
Yeah.
Well, on that progressive note, we should probably close out this edition of Radio Free HPC. This is our longest show, I think.
In recent memory,
fact.
yes. Yeah. Yeah.
We're right in there about 40 minutes. Wow.
So basically, the second half nobody heard then.
No one's listening at this point. So
Yeah.
I guess the three of us, it's goodbye, and we will be back at you soon with another edition of Radio Free HPC.
That's it for this edition of Radio Free HPC. Thank you for listening, and be sure to check back often for new episodes. Also, check out our website for more content, links, and a place for you to let us know what you think about the show. We're at radiofreehpc.com. Thanks again. We'll be back with another exciting episode real soon.